So today we're going to be doing grade 5, module 4, lesson 8, where we're going to be practicing our multiplication of a fraction times a whole number. And we're going to start off by looking at how that relates to repeated addition. So we're going to look at these problems right here. 2/3 times 6. And I'm going to show you 3 different ways that you can solve this problem. So the first way is what we're going to go back to, like our repeated addition skills that we learned in younger grades, where when I'm multiplying, I can just add things more than once. So what this is telling me is I have 6 copies of 2/3. So I can do 2/3 plus 2/3 plus 2/3 all the way 1, 2, 3, 4, 5, 6 times. And what I get when I add those all together is I'm going to get 12 thirds, because it's 2, 4, 6, 8, 10, 12 thirds. And I know that 12 divided by 3 is 4. So I can solve this. 2/3 times 6 is 4. But we've been practicing our multiplication of whole numbers the past couple of days using arrays and using tape diagrams. And so today we're going to look at how we can actually do that numerically. So 2/3 times 6. 6 is a whole number, but I can think of 6 as a fraction by putting it over 1. It has an imaginary 1 as its denominator, because remember that a fraction is really a number divided by another number. So 6 divided by 1 is the same thing as saying 6. So I can rewrite this as 2/3 times 6 over 1. 6 over 1 is the same thing as 6. Now that I have 2 fractions, I can multiply them together by multiplying them straight across. I can do 2 times 6, which is 12. And I can do 3 times 1, which is 3. Once I get 12 thirds, I can get 4 as my answer. So when you multiply fractions, you can just multiply straight across. Now, another way you can do this is the same setup. I'm going to rewrite it as 6 over 1. 2/3 times 6 over 1. I always like to rewrite my whole numbers as a fraction. So 6 over 1, because it's easier for me to visualize multiplication when I'm thinking of a fraction times a fraction, because then I know it's just straight across. And you can see, for when we did it in this middle time, we had to simplify afterwards, right? We had to look at 12 thirds and then we had to simplify it. Now, we could skip that step and do the reducing before we multiply. This way, we simplified after we multiplied. Now I'm going to simplify before we multiply. And the way we do that is we look to see if I was going to multiply this together, I would get 2 times 6 over 3 times 1. Well, before I even multiply, I can see a factor that goes into a number in my numerator that also goes into a number in my denominator, and that's 3. So I can do 3 divided by 3, and that would give me 1. And I can do 6 divided by 3, and that would give me 2. So I'm kind of simplifying it before I multiply. Now when I multiply, and I get 2 times 2 equals 4, and 1 times 1 equals 1, I get 4 over 1, which means I don't have to do any division. I know 4 over 1 equals 4. So this way is the reducing first way. You can reduce before you multiply and you'll get a simplified answer, or you can reduce after you multiply and you'll just have to then reduce and simplify afterwards. Today we're going to practice both of those strategies, and then after today you can pick the way that works the best for your brain. Let's practice it here. So we're going to continue to multiply fraction times whole numbers, but we're going to look at it in our 2 different ways. So this first way here, we have the problem 3/4, and I'm just going to rewrite it as 3/4 times 16 over 1. Remember, we always put that 1 under our whole. So 3/4 times 16 over 1. I'm trying to leave like a half line here. I'm going to multiply straight across. 3 times 16, and then 4 times 1. Well, 4 times 1 I can do in my head. That's 4. 3 times 16 I might need to do on the side, and that is okay. I get 48. So I get 3/4 times 16 over 1 equals 48/4. Now that I have 48/4, I need to simplify that. I need to reduce it down. 48 divided by 4 is what this is telling me to do. So 4 goes into 48, 12 times it looks like. So 48/4 is equal to 12, so my final answer here is 12. 3/4 of 16 is 12. Let's try it now the other way, where I'm going to reduce before I multiply, and we're going to see the difference. So I have the equation 3/4 times 16 over 1. So I'm just going to write that over 1 fraction. And then I'm going to look at my numerator numbers and my denominator numbers, and I'm going to look if there's any that I can find common factors between. Well, I see a 16 and a 4. 16 and 4 are both even numbers, and not only are they even numbers, they're both divisible by 4. So I can do 4 divided by 4 and get 1. And I can do 16 divided by 4 and get 4. So my new equation that I have here is 3 times 4 over 1 times 1. And I just rewrote it so you can see it a little clearer. It's a little messy here. So then when I do that math, 3 times 4 is 12. 1 times 1 is 1. So I get 12 over 1, which gives me 12. And you can see here we got the same answer both ways. We just solved it in different kinds of options here. The left side, the blue side, we did all the multiplication first, and then we simplified our answer and had to do this division problem. On the red side, we did the division first. We simplified the 16 and the 4 first and divided, and then multiplied. So we kind of multiplied and divide versus divided and then multiplied. And you can kind of see the pros and cons that come out of both of these options. Let's keep practicing. So we're going to do the same thing. We're going to solve this in the 2 different ways. So the first way is 10/9 times 21 firsts. So 21 over 1. Well, we're going to multiply straight across. 10 times 21 is 210. 9 times 1 is 9. So I get the fraction, the big fraction, of 210 ninths. Well, I'm going to do that division. 210 divided by 9. 9 goes into 21 2 times with a 3 remainder. 9 goes into 30 3 times with a 3 remainder. So I get 23 and 3 ninths, which I think I can simplify one more time. Let's see, 23 and 3 ninths. 3 and 9 can be divided by 3. So I get 23 and 1/3 as my final answer over here. Let's try it on the reducing first option. So I have 10/9 times 21 over 1. It's the same setup at the beginning. Okay, now I need to look to see what common factors go into my numerator numbers and my denominator numbers. Well, 9 and 10 don't have anything. 21 and 9, 3 goes into both of those numbers, right? I can divide 21 by 3 and get 7. I can divide 9 by 3 and get 3. So just like when you simplify, you have to do the same division to both your numerator and your denominator. So now I have 10 times 7, which gives me 70, and 3 times 1, which is 3. So I have 70/3, which I still need to do division here. It's not a perfectly small number. 3 goes into 10 3 times. 1/3, so I get 23 and 1/3. 23 and 1/3. So you can see that again, we're ending up with the same answer, 23 and 1/3. We just got there in different ways. On the blue side, where we multiplied first, we ended up with a kind of big number, 210, that we had to divide by 9 and then simplify. And on the right-hand side, we ended up with 70/3, which we still had to divide. It wasn't like we didn't have to do any division, but they were smaller numbers that we had to deal with. So sometimes when we just multiply straight across, we deal with bigger numbers, even though it's the more like routine base. But again, you can, after today, you get to pick whichever way you want to do it. The last one is asking us to say, what is 4/5 of 60? And they want us to solve this any way we want. So 4/5 of 60. And really we're trying to find what 4/5 of an hour is. Like how many minutes does that equal? So that's where we're timesing it by 60. That's the background here. So 4/5 times 60 over 1, because our whole number always goes over 1. That's going to be 240, because I'm just multiplying right across, over 5. So 240/5, I can do that division. 5 goes into 24 4 times. 5 goes into 48 times. So I get my final answer of 48 minutes. So 4/5 of 60 is 48. So when I'm given the choice, I multiplied straight across. You might have seen this and seen how you can simplify and reduce before you multiply. And that's kind of our goal today, is to look at both strategies and see which one you prefer to do. And you might find that on certain problems, you like to just multiply straight across, and on certain problems, you like to reduce first. I just want you to be familiar with both options for when you're multiplying a fraction times a whole number. Because now that we are advanced with our fraction and whole number understanding, we've looked at how to find the fraction of arrays and fractions with tape diagrams. We're now looking at that numerically. How can we find a fraction of a whole number numerically? And this is how we're going to do it, by just multiplying, and we multiply straight across.